Hello everyone and welcome to the third video for Cumulative Review Packet number 3. And let's start here with number 20. Solve the following system of equations. Well, solving a system, we're either going to do substitution or elimination, most likely. And because both of these equations are in standard form, I would say elimination is probably the best way to do this. And so I look at my x's and my y's, and I say, what can I multiply one or both of the equations by to get things to cancel? And I notice that if I multiplied this top equation by -3, this would become -9 and cross out. So let's see what we would get. If I distribute this in, I would have positive 9x plus 24y equals positive 72. Then if I copy the second equation down underneath it, I noticed something kind of odd that happens, and I wanted to remind you of this special case from first semester. My x's cross out and combine to be 0. My y's cross out also and combine to be 0. So you get 0 on this side equals 72 minus 48, which would be 24. When you get a statement like this and all your variables cross out, 0 equals 24 is a false statement, which means that my answer would be no solution, or that no values of x or y could work to make this true. Now remember, as a side note, if you had gotten something like 24 equals 24 or 0 equals 0, these statements would be true, which means that your answer would be all real numbers. Now, this is not the answer to this one. The answer is all real, but please just remember that as an option as well. 21 to 24, simplify the polynomials. Please put your answer in standard form. So what we need to do is either add, subtract, or multiply the polynomials. And if I look at 21, it looks like I'm taking a binomial minus a trinomial. So I am not multiplying them, I am subtracting. So what I'd have to do is distribute in that negative first. So I have negative 10y squared minus 3y cubed plus 7y cubed minus 3y, and then plus 11y squared. Now, if I want to write them in standard form, I want to go highest power to lowest. These are like terms. You don't change the exponents, but it looks like there is 4y to the thirds left. I then look at my 10y squared and my 11y squared, and I'd have a positive 1y squared, and then I have my negative 3y at the end. So here's my answer in standard form. Number 22 is a special case. Remember, this binomial squared is the same thing as 7x minus 4y times another 7x minus 4y. So if I distribute the 7x first, and the reason I'm distributing is because now I am multiplying, unlike number 21. 7x times 7x is 49x squared. 7x times negative 4y is negative 28xy. I then distribute the negative 4y to both. I would have another negative 28xy, and I'd have a positive 16y squared. So my final answer, if you notice these are like terms, would be 49x squared minus 56xy, sorry, plus 16y squared. And this answer here is in standard form because my x's are decreasing as my y's are increasing. X squared, x to no x's, no y's, 1y to 2. Number 23 is again multiplication or the distributive property because I don't see anything between the parentheses. So the first thing I have to do is distribute the 2y to everything. So 2y times 9y squared is 18y to the third. Multiply the numbers, add the exponents. 2y times negative 2y is negative 4y squared. 2y times negative 3 is negative 6y. If I then distribute the negative 4 to everything, I would have a negative 36y squared. Put that under the like term. Negative 4 times negative 2 is a positive 8y under the like term. Negative 4 times negative 3 is a positive 12. So my final answer in standard form would be 18y to the third. Combine these together, minus 40y squared. Combine these, plus 2y, plus 12. None of these terms left are like, so that's my answer in standard form. Number 24, I'm taking a monomial and multiplying it times a trinomial. So again, I'm using the distributive property to all three. Multiply the numbers, add the exponents. So I'm going to write that note again. Multiply the numbers, add the exponents. So negative 5 times negative 8, 40. X to the 6th, add the exponents, y to the 9th. Negative 5 times 7 is negative 35. X, remember this is x to the 1st, so it'll be x to the 4th power, y to the 8th power. And then finally, negative 5 times negative 4 is positive 20. X to the 3rd times x to the 1st is x to the 4th again, just like this one. And then y has nothing to add to, so it would just come along for the ride as x to the 4th. So this would be your final answer for number 24. 25. Name the polynomial by degree and number of terms. But first, we need to see if this is in standard form. It's not. We need the highest power down to the lowest. So this would need to go first. We would have negative 6x to the 4th, and then negative 8x cubed, and then the 9x is positive here, so then it would be plus 9x. Based off of that, the highest degree that I see is 4, and the name for that is quartic. And the number of terms that I see are 3, and so that would be trinomial. So this is a quartic trinomial. Number 26 is something from Chapter 7. Express the result in scientific notation if you're multiplying two things by scientific notation. So this has to do with exponent rules again. What we're doing is we're multiplying the numbers and adding the exponents. Notice that here are some like bases. So you would do times 10 to the 6 plus negative 8 power. And if I multiply the 2.5 times the 7.4, I would get initially 18.5. So right now I have 18.5 times 10 to the negative second. However, you might remember that in order for something to be in scientific notation, the first number has to be between 1 and 10. So if we look at what we have, 18.5 is not between 1 and 10. So I'd have to move my decimal over once to get 1.85, which is now between 1 and 10. But when I move this decimal, I need to change this exponent. And when we move the decimal to the left, what we have to do is add to the exponent that we have. So we'd have negative 2 plus 1, because that's the one movement I went to the left. So my answer would be 1.85 times 10 to the negative first. If you had moved the decimal to the right, you would have subtracted from the exponent. Also from Chapter 7, a word problem using these growth and decay equations. And notice there's only one, so we need to figure out which one of these three are we using. Determine the amount of an investment of $4,500 if it's invested at an interest rate of 7.5% compounded monthly for 10 years. So as soon as I see the word monthly, this represents the number of times that money is taken out per year, which represents N, which means that this is the equation I'm going to use. This one, for review purposes, is the growth exponential growth, and this is the exponential decay, because we have a plus and a minus. So we're going to have to use this equation, r over n to the n times t, but we need to remember what all these letters mean. A represents the initial amount that I'm starting with, or the $4,500. The rate is the percent that I'm investing, which is 7.5%, which in this word problem, you might remember we have to write this as a number, so we have to move the decimal over twice. So this would really be 0.075. The t is the amount of time it takes, which is 10 years. And the n is the number of times the money is compounded, which is monthly. And because there's 12 months in a year, n must be 12. So I need to plug these in accordingly. Let's have y equals 4,500 times 1 plus 0.075 over 12 to the 12 times 10 power. And so I want to remind you, when you plug this into your calculator, the first thing you want to do is, order of operations wise, you want to do 0.075 divided by 12, and feel free to do this with me right now. Then you'd like to add 1. Then without erasing anything in your calculator, whatever number you have, you'd raise to the 120th power, and then you would multiply that answer by 4,500. And when I did that, I got my final answer to be $9,504.29. So it looks over 10 years, your investment went from 4,500 to 9,504, about. Not bad. All right, the last information on this review packet is from first semester, and this is again called function notation. And what we're really doing with it is the order of operations, but I know this is going to be useful for future classes. So A is asking you to find f of -7, so to take -7 and plug it into my f function, and then you want to take 3 and plug it into your g function. The difference, though, is what are these numbers doing in front? Well, what this one means is once I find my answer for f of -7, I'm going to multiply it by 2. And this one, once I find my answer of g of 3, I'm going to multiply it by 5. So if I find f of -7 first, I'm going to plug -7 in here. 4 times -7 minus 8 would be -28 minus 8, or -36. However, I still need to multiply -36 times 2, which would get me -72. That's part 1. If I take 3 and plug it into my g function, so I really take 3 and plug it in for x, I would get 3 squared minus 4 times 3, which would be 9 minus 12, or -3, but I still need to multiply that by 5. So that would be -15. The problem's asking me to add, so my final answer would be -72 plus -15, which would be -87. So remember, you just need to follow the order of operations. Plug the number into the correct function, and then if there's a number in front, you multiply this answer by that number. Part B. This notation, also I'd like you to recall that this does not mean g times f times -3. What it means is that I'm taking the -3 and I'm plugging it into my f function first. So I'm going to leave the g, but I'm going to take -3 and plug it in here, or 4 times -3 minus 8. So that would be g of -12 minus 8, or g of -20. Now I'm not done with this problem, because the g being there means now that I need to take -20 and plug that into my g function here. So that would be, if my g function is x squared minus 4x, x squared minus 4x, whenever I see an x, I'm going to plug in -20. So we'd have -20 squared minus 4 times another -20. My answer is going to be quite large because -20 times itself is a positive 400, negative times negative, and then minus a -80. Well, this becomes a plus, so my answer would be positive 480. Again, this function notation is helpful not only in this course, but I know in future courses as well. And it's going to keep coming up through second semester. All right, guys, per usual, if there's any problems you want to go back and rewatch, please feel free to do so. My suggestion, as I've said for quite a bit of time now, would be to redo the packet if you need to. Print out another version off of Schoology. Take it in 45 minutes if you'd like to see how you would do in general on your test. As you know, your test is always shorter than the review packet. All right, guys, thanks for sticking with me. I hope this was helpful.